Hello friends, welcome you all to this learning session on PIC Microcontroller. So as long as the embedded systems are concerned, so we are going to study this PIC Microcontroller, because as we know that microcontrollers are the heart of any embedded system. So in that case, it is essence that you should study microcontrollers. So why we are studying PIC here is, which is one of the most widely used microcontroller in an embedded system. So let us start learning about this PIC microcontroller. So first thing, PIC stands for Peripheral Interface Controllers. Peripheral Interface Controller, which is one of the advanced microcontroller. One of the advanced, and this was developed by Microchip Technologies. Microchip Technologies, one of the leading vendors in this field, developed by Microchip Technologies. And why they have named it as peripheral interface controllers? There is a reason behind this, because these controllers are capable of integrating many number of interfacing ports, advanced interfacing ports, along with some memory modules, different memory modules. So the main purpose of this microcontroller was to have capability of interfacing as many as possible peripherals, including your IO ports and memory. So the first PIC was developed or announced in the year 1975. Since after 1975, there have been many number of PIC microcontrollers in the industry. So we can say PIC is a family of microcontrollers, just like your Intel microcontrollers. Okay, so PIC is one of the microcontroller family. So in that family again we come across number of PIC microcontrollers. And we are going to study one of the PIC family microcontroller. So there is not like something different about this microcontroller. So of course microcontroller is a controller itself. Like a microcontroller should have a microprocessor, that is CPU, along with your some IO ports and peripherals. So here also it is going to have, just like other microcontrollers, it is going to have a CPU along with some IO ports and RAM. But what is the difference, that we will try to understand here. And very first thing about this PIC family is, they all have Harvard architecture. So I hope, or I consider that you all know very well about some two basic architectures of any microprocessor. There are two fundamental or basic architectures. We call them as Harvard architecture and von Neumann architecture. A Harvard architecture and a von Neumann architecture. So the difference between these two is with respect to the memory. That is going to be used for the storage of program as well as data, right? For the storage of program and data. Suppose if you consider 8085 microprocessor, a basic 8085 microprocessor, there we come across a memory where we are going to store the both program as well as data. There we are storing program as well as data in the same memory, and such architecture is called as von Neumann architecture. That means in von Neumann architecture there is no separation between program memory and data memory. You are going to store the same in the same memory, the program as well as data. But if it comes to the Harvard architecture, here you will have a separate memory modules for program and data storage. The best example is, you can take 8051 microcontroller. There we have a provision that we have a separate memory for program as well as data. We call them as program memory and data memory. So This is the basic difference between von Neumann and Harvard architecture. So this PIC architecture is having a Harvard architecture. That means you are going to have separate program and data memory. And one more very important thing about this architecture is, so almost all the instructions are single word instructions. Almost all the instructions are single word, or you can say almost every instruction is of same size. So if you take PIC family, here every instruction, almost every instruction is of same size, that is 14 bit. That is 14 bit, which means each instruction can be fetched in a single cycle. Every instruction can be fetched in a single clock cycle, or single fetch, which will definitely increase your throughput, which will definitely increase the execution time as well. So you are going to have two separate buses, since it is a Harvard architecture, separate memory for program and data. So you will be having two separate buses, one for instruction, another for data, or you can say one for program, another for data. And here remember this thing, almost every instruction is of 14 bit, very important. So this is a basic structure, internal structure of a PIC family microcontroller. Basic structure of a PIC family microcontroller. This is how it looks like, internal architecture. So I will start from this right side. I will go on. So at the right side you can see there are ports, some of the ports, IO ports we can say. So they have named it as port 0, port 1. There are two IO ports, and then next to that, beneath that there are TIM, that is timer 0, timer 1, timer 2. See, you can see here number of peripherals, all these peripherals you see. Here timer 0, timer 1, timer 2, 3 timers are available. And next beneath that you see analog to digital converter. It has an analog to digital converter. Also it has a digital to analog converter. All these peripherals. And next, from the left top corner you can see here memory, the available memory, which has different memory modules, which has a RAM memory, which has a ROM memory. Along with that it also has some amount of flash memory, we can say data EEPROM. And registers, some of the important registers like your status register, and there is a FSR register, FSR in the sense file select register. What is that, we will see. And then comes W register, we call it as work register. See, this work register is similar to your accumulator, which we come across in 8085 microprocessor and 8051 microcontroller. So exactly like accumulator, here this is called as a work register W. The functioning of this register is similar to your accumulator. And then there are some trace registers, trace. So these trace registers are associated with your IO ports. How they are associated, that we will see in our other sessions. One second. So trace registers, how they are associated with your IO ports, we will see later in the section of IO ports. Then there are some other RAM registers, how the RAM is organized. In that RAM there are some registers, we will see again all these things. So putting them all together, this is like a internal structure, how you can see a PIC microcontroller. You can see the clock input there. Along with that there is a clock generator. So clock generator is necessary, as you know. And we have a instruction decoder which decodes your instructions. So at the center, see, you have a CPU which has ALU as well as your control unit. You have a program counter, once again program counter, stack. All these things are quite common in all the microcontrollers and microprocessors, program counter and stack. And there are some additional circuitries, additional modules you can call. Power of timer, right? Oscillator startup timer, power on reset circuitry, watchdog timer, brownout reset circuitry, all these things, low voltage programming. These are all the additional modules available in this PIC family. So we have two reset circuitries, that is power up reset and brownout reset. So these all modules we are going to study in detail with respect to this PIC microcontroller. So at the bottom you can see again some modules, serial or parallel ports. You have CCP modules. CCP stands for your capture, compare and PWM modules. You have USART, you have a comparator, voltage reference and other ports. So all these things you will see in detail. So that is about your basic structure of any PIC micro. So in the next class or in the next session, we are going to start learning about one of the microcontroller from this PIC family, PIC 16F877. So see you in the next session. I hope all of you like this video. If you like it, then definitely join me in the next session. Fine. Till that, take care. Bye.